Okay, recording is on, and then I'll make sure to share screen. Okay. Okay, so let's start with this. Let me just go in here so everyone can see what's going on. Okay, that's big enough, right? Okay. So um you guys all know that the end of this class is going to be like a big project submission, right? And then everything in the middle is kind of like attendance only. Just, fill out the form and you'll be good. Okay, so let's go through these items one by one. First things first, the location, the submission location. I actually decided to put on EasyChair. And the reason I put on EasyChair is because it's the same procedure. If you go through like all these big conferences, such as AAAI, NeurIPS, you're probably going to be going through the same procedure as one of these websites. This one in particular is EasyChair. And the procedure is kind of like benchmark with the same thing as if you go to AAAI. Anyone heard of AAAI here? It's kind of like one of the top 3 conference in the United States. So this one here, AAAI, it's this one. So like all PhD students, they want to make it here. If you make it here, you're all set. It's pretty much guaranteed a job if you can make it here. Me personally, I went here 3 times. It's a lot of fun. You see a lot of interesting people. Most of them are from Silicon Valley, like all the FAANG company, Facebook, Amazon, Google, Meta. Most of them are here. So that's one of the conference. This one I would probably say is more apply-ish. They kind of like focus on like projects, applications, connections with the big firms. If you really want to be like neck deep into like research, like producing like groundbreaking research at like OpenAI level, deep learning level, the one you want to go is NeurIPS. Come on in, yeah. So this guy here, that's the conference you want to go. If you want to, the same thing here. If you make it into this conference, you pretty much guarantee a job in Silicon Valley. Just because you're already in that field, you speak that language, everyone here, it's probably, I would say most folks here are probably originally the dominating group here is probably DeepMind. But I think right now, a bunch of Meta folks are there. And then if you want to do videos, I would probably recommend you go to NeurIPS. So that's another one on your list if you're interested. And of course, there are a million other ones. I would just say probably the top tier is these guys. And then obviously there's also like nature. Nature is another one, but this is not like sorry, not this particular one. Like I mean like nature in general. So let me get rid of that. Like nature in general, like if you can make it there, you're pretty much guaranteed job anywhere. Like the people who publish on Nature, they're like at professor level. So it's very difficult to get in one of these conferences or one of these papers. But anyhow, for those of you who think about um, like your career in terms of research, in terms of producing models strategically, then you want these things on your list so you can like check the list. Okay, so let me close that. Right, so now that's kind of like a long explanation of why I use this link. And the reason I use this link is because all the other conferences, they use this kind of link, and then you just have to be comfortable going through that. Now, of course, what does comfortable mean, right? What does that mean? That means you need to be comfortable producing a paper using latex. That's pretty much the only thing that you need to be comfortable with. And with today's Gen AI, you can, ask ChatGPT to do that pretty easily. And I can demonstrate an example of what that means. Okay, so now that we know that's the goal in the end, right? So let me rephrase that. In the end of a semester, everyone's gonna submit their work on that website. And then you can just go in here. I can show you real fast what that looks like. It looks like this. And then there are a couple of guidelines that you can read about. But the most important thing is this one. You just click on this one, and then you just create an account, log in, and just drag and drop your paper in there. And paper, I'm talking about like a PDF document, right? So it should be fairly easy. All you gotta do is register account. That's it. So I'll leave that there. And then now let's talk about that final paper or poster, whatever you want to choose. That's totally fine. Typically, in one of these conferences, it's one of two options, right? Yeah, come on in. No worries. So typically in one of these conferences, it's one of the two options. Like you either write a paper or a poster, right? And both both formats are on this website called Overleaf. Anyone heard of Overleaf? Because some of you heard of it. On Overleaf, there's no strict requirement you have to use Overleaf. The only reason to use Overleaf is because they have template, and you can just load up one of their template and you can just start typing things down. So I'm going to spend a few minutes talking about that in just a sec. But that's pretty much where things are. So one of two options. Maybe I should make this clear. This is like first option, a paper with at least 3 pages. 3 pages is kind of like it's actually easier. It's actually very easy to do 3 pages. Because you can ask ChatGPT or make the spaceline like 2 or something. And then 3 pages is like probably 5 paragraphs with like a couple pictures in the middle, a table, and then a couple of references. So 3 pages is actually very easy to do. So that's kind of like the bare minimum for first option, if you choose to write a paper. Now, there's another option, which is poster. Poster, I don't want to go crazy. If you can do a poster and do it well, you can just do it in one page. That means you have everything in that poster, right? Table, whatever. Citations, there's like a standard format you can do. I'm going to show you what that format looks like. But pretty much it follows like a standardized data science pipeline. Like you have a data and then like you build a model or whatever, and then here's the results, and hopefully your results is better than the benchmark. Yeah, so that's the poster. And don't worry about, like, if you have no idea what I'm talking about, I'm going to show you guys what the template looks like in like literally 5 minutes. But I just want to go through these items first. So that's the paper and that's the poster. And then obviously naming convention, just follow the naming convention so that I can look up people's names so I don't miss anything. This is kind of like for my purpose, just so I have a standardized way to track which paper, just so I don't lose your paper. That's all. Okay. Now this one, I'm actually gonna enforce a video this time because it's just such an important thing. Like I've gone through recruiting calls that they saw my video and then they pass on the coding interview. So it's like I'm doing you guys a favor on this. Like if you can pull this video up and then you show recruiters that, there's a chance they pass you on the coding interview, and it's a huge relief on your job hunting process. Not 100%, but it does happen. So take it seriously. In my own personal experience, if you're able to write a paper, you know what to talk about in an interview, or you know what to talk about in a video. That's almost like 95% guaranteed. Unless you're like shy or something, then that's totally fine. Just turn the video off. I mean, you don't have to show your face. I mean, you can just walk to the paper, right? You can just walk to the poster. And then as long as you enunciate and you say things clearly, you don't have to show your face, but like you can say, hey, I built an app. This is how the app works. You can talk to it, whatever. This is a poster. This is the results. This is a table, whatever. Then that's kind of like serve the purpose. So that's that. And I'm going to explain what that is. And then last thing, just latex. And I'm going to demonstrate an example in just a minute. Other than that, just watch out for deadline. I prefer deadline to be before December 5th. Now, that being said, if you take more time, I don't expect anyone to. Usually, for a project like this, people prefer to get over with earlier than later. So respect deadline, but if you truly can't make deadline, just email me saying something happened, you need more time. I'm pretty much linear with that. Okay, before I go into the Overleaf, any questions so far? Just logistic-wise. Okay, now let's go to Overleaf. So overleaf.com. That's my account. If it's the first time you're logging, obviously you're not gonna see these papers. You're probably just gonna see a blank one, and then that's totally fine. I would recommend you start from top left corner, click on new project, and then say, scroll down, and then this thing here, you probably won't be able to see it, but it's called View All, like this button here. And then now you can search for different templates depending on your choice. If in the first option you were choosing paper, I would just make your life easier. I would probably just go to either archive or AAAI. So archive means you search archive and then there's template there. Or if you want to go to AAAI, it's actually very similar template. There's a template there. And just choose one of them and then you're good to go. So you don't have to decorate like, oh, I have to write these 5 lines to make it 2 columns or some crap like that. Like, there's no point spending time there. So pick one. Let's say you pick that one and just say open as the template. And then from here, you can then take it over and do what you need to do. Now, of course, you don't have to go in that kind of detail. I would say the bare minimum. I would think about what the abstract look like, and then I would think about a couple of things. I will have a table and a picture, and then everything else is just plain paragraph. A table and picture is probably what I consider like the bare minimum to tell a story. Like if you have an app, then the table probably have a good summarization of what the app is doing. Same goes with data science project. If it's a data science project, then the table pretty much summarize what you're doing. What else? Let's say you are let's say you're building an app. An app typically have some sort of graph. And once you have code, the graph is super easy. You don't really have to write it like line by line. You can have ChatGPT generate that. And I'm going to give you guys an example of what that means and just tag that into the paper. So I'm going to show you guys this and I'm going to leave this here. And then I'm going to carry out the class lecture. And then in the end of the class lecture, after all the demos, I'm going to then show you guys how to generate a picture. Because once you have the code, you can generate a picture very easily. And then you can upload picture here. And that's like a third of the paper, probably one of the page, which is a third of the requirement. And same goes with the poster. So I'm going to leave this here. We'll come back. End of this lecture. Okay, now you can go to same strategy. So go back and then go to view all. And then if it's a poster, I'll probably do this. Any one of these posters template is fine. I'll probably just click on the first one from Oxford. And then you can just fill this up based on whatever project you're doing. And I can probably show you an example in the end as well. They're really the same thing. The only thing the only thing I worry about at this moment is just working on that project that you want to do in the end. The most difficult thing is actually not the paper. I will probably say the most difficult thing is what is the project? Because everything after that can be done with large language model. But you need to figure out what is the project, and then that's probably the most like based on my experience, it's probably the most difficult thing. So paper template is here, and then each one of these bullet point, it's editable from basically these blocks in the middle. And this might look scary for you, but don't worry, that's what large language is for, right? That's what AI is for. AI can write a table for you, and you can just copy paste the code in here. And I'm going to demonstrate an example in the end. Any questions so far? Okay. That's that. And then let me go to announcement. So that pretty much sums up the announcement that I posted earlier. And then let's see. So today is Friday, September 26th. So I would say from today all the way to December 5th, you guys have like quite a long time to work on this. Like it shouldn't take you 2 months to do 3 pages. But let me know if there's any blocker. Like if you ask me for my personal preference, I would probably say if this is my schedule, let's say today you tell me you need to submit something December 5th, I would probably spend like 3 to 4 weeks worry about what is it that I'm doing. Like really what the reason is, why do I want to do this? Why is it good for my career? Don't worry about grades and stuff because everyone's passing, right? Just worry about like this is one opportunity in your life that you can do whatever you want. So just do whatever you want, right? Find that true passion of yours. If it's healthcare, it's healthcare. If it's finance, some people like finance, then do finance. I think someone emailed me with sports, then figure out what that is, right? And once you pick that topic, you can then think about, okay, am I thinking about this as a data science project, or am I building an app of some sort? And then you can figure out, okay, what's the data I should be using? What's the app going to be looking like? And what is a model going to look like, and so on and so forth. Make sense so far? So if you tell me to do this right now, and I have to December 5th, I will spend like 3 to 4 weeks worrying about what that is. And then that would probably take me to September 26th, let's just say 4 weeks. So that will take me to end of October. And then from end of October, I have like entire November to work on this. Does that make sense? So that's probably the milestone I will personally do. Now, of course, some of you already know what you want to do. Then obviously, you have like, let's say you already decided to work on finance today. Then you have 2 months to work on it. That's kind of like the difference. So yeah, I think that's pretty much what's happening here in this announcement. Any questions? Logistic-wise, any questions? Good. Yes. Great question. Is it a group project or individual? It's an individual project. So you can do whatever you want, pretty much. Yeah, it's a good question. Any other question? Good. Okay. Cool. I can probably close this. And then the plan for today is this. So previously, I'm trying to give you guys as many tools as I can. So previously, we talked about Gradio app, right? You hop on Gradio app, you can download a model, and then you can set things up, you can talk to it. There's backend, there's a front end. That's how you build things, right? That's how you build apps. That's how you build projects. So we're gonna continue the lecture in that framework, in that spirit. But I'm gonna give you guys more and more tools. And obviously these are recorded. So hopefully sometime in November, when you guys make that decision, you want to do something, and then these tools are at the tip of your finger. Make sense? So today what we're gonna do is actually pretty fun. Typically, when people handle voice, it's usually a fun project, and that's what we're gonna do today. So I want to give you guys more of an end-to-end framework of chatbot and what happens when you have a database behind a chatbot and how things could work. In the industry, this is well known. It's called text to SQL. So you write a text, large language model will write SQL code for you. It will query a piece of information from a database, and then it will spit that data back in front of you on that chatbot. Now, I'm using a fake database, but in your project, it can be pretty much whatever you want. It can also be synthetic. Don't be afraid of using synthetic data, by the way. I don't like I know this is a school project. I understand all that. Like some people ask me like, do they need to like collect some animals or something like that, like pass like human approval or whatever? Like no. There's nothing like that, right? Don't go crazy on like we're talking about data set that you can either download from the internet or synthetic data that's generated from LLM. So don't go crazy on data set. The important thing is the know-how, because once you go in the industry, like don't worry about it. Someone will give you data set for sure, and you just need to worry about how to use it. Last time we talked about RAG algorithm, right? Retrieval augmented generation. Let me just start with the picture so people can know what I'm talking about. Pretty much either one of these pictures will do. I mean, that's perfectly fine. Oh, yeah, I mean, this is perfectly fine. This has been done so many times in the industry. So it's a pretty standard format. Like you can't find a job now as AI engineer if you have no idea what this picture is. So you kind of have to know what this picture is. So let me start with the motivation first, because that's kind of like more important than why you even need to do this in the first place. So motivation, why do you even want to do this? Two main reasons. One, the assumption is fine-tuning a large language model, it's not an available option for you. Why? Well, for obvious reason, right? GPU is expensive. You need to hire expensive engineer to help you fine-tune large language model. Let's suppose that is not available for you, right? That's assumption number one. Assumption number two is if your data is private, again, for obvious reason, right? It is totally believable that some companies say, okay, I don't want my data to go out of the door. This is my data. I want to protect whatever security purpose or whatever customer's privacy. For obvious reason, they want to make sure the data doesn't go out of the door. So because of those two reasons, it gives birth to why people want to do this at the first place. So let me explain a little bit. You first of all start from data. This can be your raw data. It can be your whatever, PDF, Word document, Excel, some website or whatever. Like it can be pretty much anything. You need to have a little bit of a domain knowledge. And usually the data engineer highly recommended, and we're doing this, I'm doing this in my day job all the time, like highly recommended, the data engineer need to work with the product manager to figure out what is the best approach to basically chunk the data. What that means is you need to cut these data into little pieces. And the reason you do that is because you want to then send those little pieces into a LLM to generate the embedding. And that will take you from this location all the way to here. And once it becomes embedding, you can then send that embedding into some sort of vector database. And this can be like a, you can think about it as an Excel spreadsheet, like a table with rows and columns. And then inside of that table, there are a bunch of information that your company needs. Okay. Once you're here, then the user is going to ask something. So whatever query is, hopefully, presumably, user is asking questions about a database. If user does not ask questions about database, which of course can happen, then that's a kind of like an edge case. Then we discuss that scenario separately. But if the user asks questions about database, then the user question can also be sent into an LLM to generate the embedding. And that embedding can then go into this vector database for you to then find a similar content. So all that's what we did last time, right? With the Milvus package, and Milvus package will pretty much take care of all that for you with like 5 lines of code. And then it will retrieve the relevant content, and then the relevant content can go to a foundation model. Foundation model here is pretty much whatever LM you want of your choice. And then you generate a final response. So that's what the RAG stands for, retrieval augment generation. So you retrieve something, retrieval. Augment just means the retrieve information is augmenting the LLM's memory base. So that's augment. And then generation just because it's a Gen AI tool. So that's what those 3 letters mean. So this diagram, you kind of have to know. And then what we're going to do today is kind of like a build on the philosophy of what we did last time. So what we did last time is pretty much this central component in the middle. That's what we did last time. And this time, we're going to pack everything together in a chat box, right? So before I continue, any questions? Any questions about what's happening here or any questions about the tools? Okay, great. We're going to do this nice and easy. So let me close this. We're going to do this nice and easy. Let me take you here. Okay, so the branch is 2025 fall. And then if you go into this folder, go into deliverables, and then it's in this folder called Chainlit MCP SQL demo. And then the repo is here. So if you click on this, it'll take you to this repo, and then everything is in the demo folder. And we're gonna do this really like slow, step by step, and then everything's recorded, right? So if you wanna reproduce this, so hopefully you can. So what I'm gonna do is this. So I'm going to put my terminal window here, and we're gonna do everything in terminal window. Is that big enough? Could probably make it even bigger. Okay, so nice and easy, right? Go to the repo, copy the URL, come here, and then what I'm going to do is I'm going to go to a folder I created earlier so I don't overload my desktop. So CD in there. CD stands for change directory. Okay. And then I do a ls. Oops. There are all these test folders. Typically, what I do is I just create a test7, and then I do change directory test7. So this means I'm creating a new folder down here, and then immediately I'm going to that folder. So PWD means pre-working directory, and that's the directory I'm in my computer right now. Great. So now it's empty folder, right? Because I just created. Now I'm going to clone the repository in here. So clone repository means, well, first of all, assuming that this is a public repository. If someone is private, then obviously, it's a separate conversation. But this is a public for now. So again, I'm clicking this green button and then copy the URL, come here, and I'm gonna say git clone and just paste the URL down there. And I'm just gonna hit enter. So it's going to physically copy all of the artifacts from that URL to your local computer, right? Okay, so now I can do a ls, and then I can see this folder here. So I can then cd into that folder, chainlit, whatever. Now I'm in here. Now let's take a look at what's in here. So there's a demo folder, and these two things is just kind of like just there. You can kind of just ignore that. So you can cd into demo folder, and then you can list out the artifact, and there are a couple of artifacts. So right now you can kind of already know that there's a UV log here. UV log means I'm using UV as a package manager to log all of the versions of the package that it's being used when this app was initially created. So instead of doing pip install 50 times and then match the package version to whatever the repository that you just downloaded, now it's very simple for me. I can just do UV sync. Before I do that, let me check the VPN. Let me disable it. Okay. So now I can just do UV sync, and then it will automatically download all the packages and benchmark the versions with the versions that the app was originally created. Make sense? So you don't have to do pip install 50 times and make sure all these numbers are correct, because that's annoying. Okay. Now let me clear it up. All right, so now you're pretty much all set, and I want you guys to see the error first. So if I do UV run on the package, UV run chainlit run app.py, I'm pretty sure there's an error, and I want you guys to see the error. Hang on, let me make sure. Okay. Where's the error message? Oh, it's here. Your app is available at localhost. So error hasn't shown up yet. Let me go to localhost, so that you guys can see what the error is. Okay. So localhost 8000. Tell me about the database. And then at the moment, let me go to terminal. Okay. Can anyone guess why this error shows up? Take a wild guess. It's actually easier than it looks. Yes, yes, your API key is not there, right? I didn't set API key, right? Everyone got it? So you can use large language model to write the app for you, but pretty much all the way to this step, you kind of still have to depend on your own eyeball to be able to tell that. Now, is that really true though? I mean, if I'm really lazy, I can just copy this into ChatGPT and say, hey, explain this error to me, right? But obviously, if you recognize it, that's much faster. Yes, that's good you caught that. So I just need to get the API key, right? That's all there is. So cancel. Let me clear this up. And then I'm going to grab the API key real fast. And then I am going to get the API key in there. And this is how I would like to do it. There are obviously more than one way to do it. So give me just one sec. Let me grab my key. Okay. Now let me go to terminal. Do a cat app.py. So cat app.py means I'm doing concatenate all of the statements in that Python script onto the terminal window. Basically, it just means print out everything in that Python script. So I saw this. That means the secret based on this code here is loaded from a file called .inf. That's what that means. So that's pretty much it. That's all I need to know. I can get rid of that, clean this up. And then is there .inf? No such file, so .inf. Great. Now I can do a nano .inf. Okay. Now I'm in the .inf file, and this is the edit mode. So it allows me to physically type things down in the .inf file. Great. So now I need to know what to type down, right? API key, exactly, but I need to know the name. So let's take it easy. So let's go to add.py, and then I need to find out what a variable name is. So it's this thing, right? And it has to be exactly that, right? Capital A, capital N, underscore, whatever, like it has to be exactly that. If you miss out on one of these letters, then obviously it doesn't know what the variable is. Make sense? So grab that. Now I can clear things up. I can go to our inf, put it there. And I'm gonna have to put my API key here, and I have to cut this part off before I put it on YouTube because I don't want to expose that. Okay, so once I put my API key in there, good to go. Then I can just exit. So exit. I say yes. I hit enter. Great. So the secret's in there. Now I can do the same thing, and hopefully everything will work. So let me make sure the command is correct. Chainlit run. Okay, so I see this. Great, that's good news. And then I should just be able to wait a little bit before everything happens. Localhost 8000, great. Let's go to localhost 8000. And let's refresh. Okay. Now I can probably start talking to it and say, how many rows are there in the table? Come on. All right, let's see if we get it right. There's a couple of things happening here that's interesting. And I want you guys to see what this is. And we're going to have to go to the code to make some edits. But it's important to see why that's the case. So I haven't shown you guys the code. Obviously, it's very difficult to understand why this happens. But just kind of like, I want you guys to just kind of like experience this. While you're reading the content here, I want you guys to think about why it happens. And it'll be really helpful if you can kind of just think about the logic, why that happens without code. If you can get that, that's super helpful when you then look at the code. So I said, how many rows are there in the table? And then the app said, to find out how many rows are in the table, we can use simple SQL to count all the rows. And here's what it is. Okay, what is, like, before you continue, what's wrong here? What's the problem here? Can anyone guess what the problem is? You didn't give table names? Exactly. So no one ever said table name, right? This user underscore transaction is made up. Now, it's fine if you want to make up, but the question is, whatever the LLM is making up at this moment, is that even the correct table name? If yes, then you will probably run correctly. If it's wrong, then the SQL code is not going to work. Because when you execute the SQL query, it's going to find that table name. And if the table name doesn't exist, then obviously it's going to give you an error, right? So it ran it. That's what it's trying to run. And then it got this error. Make sense? And the error is very simple. It's exactly what it says here. The table doesn't exist. Okay. So now what's going to happen is it's going to try to make something else up. Now the question becomes, is that the correct name? You guys get the idea, right? And then it's going to execute that query. And then it can't find that name. Make sense? And then it's going to keep going until it gets the right name. So anyone can guess what the solution is. Exactly, give a table name. Yeah, yeah. Okay, so now let's go to this code here. Let's cancel it. And then somewhere in this app.py, we need to figure out what the table name is. So that's what's happening here. So typically what I do is cap app.py, and then let's go up. Let's take it nice and easy. Let's go from beginning. Okay, we saw import. We saw Anthropic API key, and then we saw there's a fake table. Where's the table name? The table name right now, it's defined as sample table name. So obviously it doesn't know what the name is, right? You're trying to guess like transactions or something. Like that's obviously not that. And then let's see what else. System prompt. You are a SQL assistant. Only output a select SQL query instead of a markdown block, blah, 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 blah. This is a schema, and that's it, right? So this is a system prompt, and there's nothing here that says anything about the table name, right? So from here, you have two options. A simple option, if you don't want to change the Python code, the simple option is just to tell the app, say, okay, the table name is exactly whatever this is. Or you can go into the code and then make sure the table name exists in the system prompt. So we're going to do both, right? So let's clear this up. Okay. The table name is, I already forgot what the table name is. Sample table, thank you. Sample table. Is there more? Name, okay, thank you. Okay. How many rows are there? There we go. So now it recognized that's the name, and then it run the SQL query, and then it run correctly, it got 4, right? And then it says, okay, the table name is 4. Sorry, how many rows? There are 4 rows. Make sense so far? Okay. So there are a couple of things happening here. First of all, there's a rag, right? There's a rag. So you the rag here is this piece of information that's 4, right? Large language model has no idea the table has 4 rows, right? It only knows the table has 4 rows because it executes a SQL query. The SQL query says it's 4. Make sense? So that's rag, and then presumably the table is also something like a private table in the company's database. So that's what's happening here. The large language model's function here is merely this 2 lines. So it take a look at what you wrote, which is how many rows in the table are there, and then it created these 2 lines of SQL query for you. And then it runs the SQL query for you. So it writes SQL query for you, it runs SQL query for you, that's it. Like that's what's happening in the back. Make sense so far? Okay. Now that we understood this and we saw this what the app looked like, then let's go back to the code. So let me go back to the code. Let me shut this down. Now I can open the VS Code. Let me make it bigger. Okay. This is an entire script here. That's what the whole thing is. The entire front end and back end is completely coded in Python in one Python file. The benefit there is to use Chainlit. Anyone heard of Chainlit? Heard of Chainlit? Okay, so Chainlit is basically very similar to Streamlit application, also very similar to Gradio. I would probably say it's a little bit more advanced than Gradio because of the user interface design. And then it has like plugin MCP, if that's the direction you want to go. And MCP here stands for Model Context Protocol. What's happening here is I have API key set up, and then I create a fake table. In your case, this PD data frame can be pretty much any Excel file that you load in. And you either have Excel or not, right? If you have Excel, then load it in, right? Read CSV, whatever, from Panda. If you don't have Excel, then that's where the data engineering skill comes in. Like, let's say you have a PDF document, and then you can read the PDF document, and then you can chunk it into different parts, and then you can generate an Excel file, and you can do that in a separate Python script. And then once you generate the CSV file locally, then here you can just say pd.read_CSV. And then everything else will continue to run. Make sense? So I did it in this way for that purpose because presumably everyone will be having their own data when they're handling their project. Here, I try to keep everything simple, so I just use SQLite in Python. That's probably the easiest database you can build. It takes probably 2 lines of code to stand up that database. You can do it fairly quickly in the Python script. Now, just be aware, this is a stateless database. Anyone know what that means? Raise your hand if you know what that means. Like, take a guess. What does that mean? Stateless means doesn't have a state, right? So you want to take a guess?
It's not hosted.
Exactly. So it's not hosted, meaning that every time I run the script, it will have like a new memory, right? It will start with a clean slate, right? It doesn't remember what's happening before, right? Because the database is not saved anywhere, right? That's kind of like the reason. And it's not hosted anywhere, right? So that's the reason. Okay. The reason I mentioned this is because if you are having a custom CSV file, then you might need to recreate this table on the spot, if that's the way you design it. Now, alternatively, you can probably have a separate Python script to stand up database, and if you want to do things that way and host that locally, that's also fine. But for the sake of final project, this is like, it will get you past the finishing line, and it's perfectly fine if you just want to do a stateless. Make sense? Okay. System prompt, it kind of depending on what project you're building. In this particular case, I need the LLM to give me SQL code. So I wrote the system prompt this way. And I also know my table look like this, right? Look like this means there's 5 columns, and a column has like whatever, user ID, username, or whatever, right? Transaction ID, something like that. So I put the schema in the prompt. When I say schema, it's just the format of the Excel spreadsheet. That's what schema means. It's just the rules of the Excel spreadsheet. In your case, your schema will be dependent on your CSV, which obviously may or may not look like this. So probably will not look like this, just because it's your project. Make sense? But my recommendation is, in your system prompt, you give it as much information as you can. So downstream, the LLM pretty much knows what you're looking for.
JSON.
Yeah, if you want to put in JSON, that's also fine. Yeah. Let me take a pause. Any questions so far? Okay. Let's see. Okay. So extract the SQL code from cloud response. This function, what it's doing is it uses regular expression. So that's what this package means here, RE. That means regular expression. So it's physically going through the response from large language model, and then it look for SQL code. That's what this function is doing. So the reason that you need this function is because the original response from LLM is going to give you like a giant paragraph with SQL code inside in like the fifth sentence or something like that. And you don't know if the fifth sentence is SQL code or the fourth sentence is SQL code. You can only find it using the pattern. That's what this function is. So you found that, and then whatever the SQL query is, then you need to run the SQL query against the database. So that's what this function is doing. It takes the SQL query. So presumably everything goes inside of this function. It's only SQL query. And SQL query just means it's something look like this. It's something that look like this. So select count as from blah, blah, blah. So it should look like that. If it's a regular sentence, if it's like something like this, then obviously it's going to be a problem, right? So that's what this function is doing. And then it will go into the engine, connect. That just means go into database. And once you're in the database, you will read the database according to the SQL code. So that's what this PD read SQL means here. And again, all these stuff can be written by large language model. I'm explaining just so when you read the code, it's easier. But you know, in no scenario should you try to memorize all of this. Make sense? Like this stuff is all here, and you can ask LLM to explain to you. Okay, so far, what we have done is all of the helper functions related to SQL query. Now we can probably talk about streaming. So one thing that I don't know if you guys noticed is the LLM response is printing out the response word by word, right? And the reason it's able to do that is because here I have this function called .stream. .stream is designed in a way that instead of waiting for the entire response to finish and then print the response in front of you, it's taking a token by token and print it token by token on the screen, which means there's need to be some sort of for loop there. So that's why this for loop is here. And all it's doing is instead of waiting for the entire response, every time there's a token being guessed by the LLM, it's printing that out immediately. So in terms of user experience, it's just a little bit more comfortable because you're seeing the response being printed as you're like reading the response. And that's really the difference here. Alternatively, you can probably do this in like maybe instead of like 8 lines of code, you can probably do this in 1 line of code. But then the problem with that is the user experience is going to suck, right? Because then you have to wait for the entire SQL being generated and then SQL query being run against the database and then generate the final response and then augment the response. And then you wait for all that to finish, which can be like 20 seconds. And in terms of this kind of project, that's kind of like painful to wait. Make sense? So that's what this function is doing here. So once we go through that, this is just start the conversation. And the benefit of Chainlit is they have these decorator that you don't really have to do much in terms of user interface. Like remember Gradio, we have to say, oh, here's an app. And in this app, there's a box, text box, there's an image input, there's a text output or whatever, right? You have to physically type that out. Sure, that's easier than already, right? It's already easier than HTML. But you still have to do something in terms of Gradio code. This line of decoration, like this kind of stuff, like when you see an @ in Python, that means it's a decorator. So the decorator already behind the scene knows that this is a function that not only is a function, but also there need to be a user interface to back that up, to front it. So this line of command on line 84 automatically does that for you. So in this particular case, and only in this case, if you're using other package, that's a separate problem, right? In this particular package, aka Chainlit, the UI and the front end, it's built inside of the backend. So there's no additional front end script per se. Does that make sense? Any questions? Okay. So the short answer of that is you do your backend stuff, whatever function you need to build, whatever LLM you need to call, and just tag it with the chainlit decorator, and the front end will automatically show up for you. That's what that means. And again, you don't have to know, like you don't have to memorize this thing. Like LLM can write that for you. Make sense? Same goes with message. Whatever message that you are using, this decorator here will automatically design a front end for you. And this message in the middle, it's pretty much same thing as we always talk about in terms of LLM API call. The only difference is this tool calling. And this tool calling is kind of like dependent on the LLM framework that you're using. In this case, I'm using Anthropic Claude. So in the framework of Anthropic Claude, whatever response that's being generated from Anthropic Claude, they actually have a stop reason in that response says, okay, this is tool use or it's not tool use, like a message or whatever, calling tools or something like that. And I'm using that stop reason as a signal to let me know if I should continue the conversation or if I should execute the SQL query or not. So that's what this line is doing here. And then I think everything else is probably kosher. This you don't have to worry about for the moment. You only, in terms of what we're doing, which is just SQL generation, you don't really need MCP. That's kind of like overkill. So for now, you can just kind of ignore that. But pretty much up to line 125, it's all you need to know. Let me take a pause. Any questions? Okay. Now let me go back to the UI. And then let me explain a little bit about the UI. Localhost 8000. Okay, so where's the other? Sorry, just give me 1 sec. Okay, now I can probably link everything together. So, what did I just do? I built an app, I run it, and then I talk to it. That's all I did, right? I demonstrated that you can talk to a database. That's it. That's all I did, right? If that's the project that you're doing, obviously you will be using a different data set, but if that's a project you're doing, I would say that pretty much suffices what that video is. Does that make sense? Pretty much everything exactly what I just did. You fire up the app, you say, this is an app, I can talk to it, and the benefit I can talk to it is because I have this magical database that I put together. And then you talk to it, it generates a response back, and then you explain on the video, say, okay, this is how the response is generated. We use SQL query, we use whatever. And here's the database. And altogether, I expect that 2 to 3 minutes should probably do the job. Any questions? So when I say, so in this announcement, when I say video, that's what I meant. So you should not, yes.
Going to explain what it's not about it or like why it's what it is. Like the first line is describing something that's significant to the field.
That's a good question. I would say you should at least talk about why you like it and why you choose it. Like you don't have to go through 50 papers to explain the academic gap of the literature, not to that level, but you should at least explain, hey, you know, I like this, I'm interested in this because people need this tool and currently there isn't any, at least to that point. Make sense? Yeah. Like if it's sports, like you mentioned about sports last time, you say, hey, you know, I know that this platform is needed. People want to, there's scouts looking for a football player or a soccer player, but currently there isn't any. That's why I'm interested in building this app. Boom, that's it. That's your reason. That's the motivation, right? So at least something just, you know, from your heart. That's pretty much what I'm looking for. Yeah. Now, that being said, if you want to read 50 papers and say, okay, I read these papers, none of these papers explain this, great. Then that's your prerogative. You can do that. You don't have to. Yeah. Okay, that's a good question. Any other question? Okay, awesome. It's come out of the clock. So let's take a break. So for 7:06, let's just come back at 7:20. And let's take a break. Okay. So let me say a few words about this and how it ties up to the paper and poster. And then we'll talk about voice. And then after that, we're done for today. Okay. So let me take your attention here, right? So what we talked about earlier in the class was, okay, final in the last part of the semester, we're gonna do this project, and then this is this big submission, right? So that's what we talked about in the beginning. And then I said you can use Overleaf, which give you latex, and then you can type in your work in there. I would say if let me take your attention here. Either one of these options, I should probably make this clear. This is option one, this is option two. I'll just write that here right now, option one. And then here is option two. And I'll make it clear that like you only need to choose one of the options above. Okay, so doesn't matter which one you choose, there's gonna be some sort of picture in there, right? Poster has a picture, paper has a picture, there's gonna be some sort of picture in there. This is how I would go. So you go to your code, whatever code that you have here, could be a chatbot, could be an app, could be whatever data science project that you're doing, right? There's some sort of code, right? This is probably how I would do it. So just copy, paste the entire thing, just select all. And then my personal preference is go to some sort of, just go to your favorite large language model. In my case, I like Claude. So I'll go to Claude and I can probably open a new one. This is what I would do. I would say I have a Python script about a text to SQL app. Paste the script in there. It'll become attachment. I'll say see attached. I want you to give me a mermaid diagram. Sorry, a mermaid code of a diagram. I want the diagram to be sequence diagram from left to right. And that's it. That's all you need to know. And then at the moment, what's happening is it will read a Python script that you attached, and then it will write out like this syntax here on the right-hand side. And that's the syntax for mermaid code. And once it's finished, I'll show you guys what that looks. It will probably render automatically, but there's a different place that will show you guys what I look like. So this is what it look like if it renders it, and you can zoom in or whatever, do what you need to do. If you want to read it, or if you want to edit this, you can pretty much take it to go, right? You can add more, or you can just take it to go. Let's say you're happy with it. Let's say this makes perfect sense to you. This is what I would do. I would just copy, and then I will go to a browser, go to Mermaid, and just put in here. That's it. And you can read about it if you want to. You can edit here if you want to. You can use large language model to edit it if you want to, right? Once you're done, let's say you're happy with this, then all you gotta do is share, and then I forgot which one. I believe it's this one. Export, save as SVG. Hang on one sec. I think you should be able to save as PNG. Oh, you have to log in. My bad. Let me log in first. Correct. It's free. Is it? Sorry. I have to find the login first. How do I log in? There's a button somewhere here that allows you to log in. Am I blind? This one? Oh, there we go. Okay. There we go. Okay, now go here, refresh, and then say share, copy this. Now you can export, PNG. Okay, there we go. It's free, by the way. You don't have to pay for it. Yeah. And it's going to generate PNG, and the PNG is basically this thing, like this diagram here. And then you just say whatever this is, open that. It's going to be in a download folder. Okay, now once it's downloaded, you go here, and then if it's one picture, then you can just upload in there. But typically, what I do is I create a new folder called Fix, and then I like to put figure in one folder, table in another folder, so on and so forth, just to be organized. So upload, and then I go to my download folder. Literally, I'm just going to drag and drop here, just like that. Okay, once it's done, this is what I would do. This is where I upload images. Figure. And then I would probably say, I mean, that's it, right? The first one pops out, that's it. But if you don't know where it is, go with the folder name, and then you can just select this one that pops out, and that's all you need to do. And then I will probably just go with 90% of the language just so it looks bigger. But you have to kind of play around with that number a little bit because this is 2 columns, right? So sometimes it might get cut off, but whatever, like you can just render it. You can click this button and then let's see what's going on. Is there error? Graphic X. Sorry, that's my bad. Use package. Graphic X. There you go. That's it. There you go. Okay, so if that's not clear, then you can probably say scroll above, copy that, and then you go here, you say this is my latex code, but it's 2 columns and I can't see the figure. Can you make the figure in 1 column? And you should update the latex code for me. And then I just need to copy paste that into the Overleaf file. It has a couple of options. Let's see. This is to keep in 1 column. Is there one that makes it into span both columns? I don't know if this is it. Let's see. Isn't that just what I have? Let me take a closer. Is there more edits down here? Oh, it's a star thing. Okay, I see it. Sorry, I didn't see that earlier. So I put it here with a star. I don't know if that works, but let's see. Okay, there you go. So this should be at least a good, like, at least a good starting point for you guys, and it takes like a page already. So if this thing takes 3 pages, what I just did is just 1 page. Makes sense? And it's perfectly fine. So the bar is very low. It's not meant to be hard. it's just certain steps, and there are certain ways to use LLM, to use AI tools. You just need to know how to use it, right? In the old days, before large language model, we have to actually remember the syntax. If you don't remember, you're gonna have to Google it, which is kind of annoying. But today's large language model just replace the Googling part, right? Googling part is just a matter of a patience of reading through like the first 10 pages on Google links, right? Google give you links, right? Today's LLM is just memorize all that for you, and then it just give you that out of the box. Okay, any questions? Okay, good. So that's kind of like a long answer of how do you go from your code to picture, and then how do you go from your picture to paper, right? Okay, so we can probably close that. And then now, finally, we can talk about the fun stuff, which is voice. I can probably move that away. Okay, so voice. I like to, I'll show you what the end result look like first before I explain the technical part, because it could get really tedious. Because it's, long story short, it's gonna be a bunch of API calls like from left to right, that's it. So instead of just reading off this, which most professors will probably do, I'm gonna show you guys the app first, and then you know what? Let me start with a system diagram, and then I'll explain what the app look like. So I'm gonna open that, and then I am going to run this while I explain to you guys what's going on, and then we'll run these app one by one just so everyone's on the same page. But this is the sequence diagram. I'm using this for my own class material as well, just because it's easier. Okay, this should be big enough. Okay, voice. A voice chat, as opposed to chatbot, is essentially the interface now becomes using microphone. That's it. So microphone means it's not typing, right? You talk to it. Means your mic needs to be on, and then you need to have some sort of function inside to turn the audio into text before you can send the text into a large language model. And then everything else flows afterwards. So this is the procedure. So you start with the user, or you start to be on your browser. And then what's gonna happen is you're gonna hit the Gradio interface, and we're back to Gradio app. So now once you hit the Gradio interface, at the moment, the first step is record your voice using a microphone. So there's gonna be a widget on Gradio that turns the microphone on, and you physically talk to it. That's step number one. Okay. It takes the audio and is saved as in a temp location. Because if you don't save in a temp location, you can't physically send the audio file to the API call. Make sense? So you kind of have to save it. So you can kind of imagine why the data center is huge, right? Like we talked about in the first lecture, the data center is huge. It's because all these like junk files in the middle, that sometimes people save it. Like I'm pretty sure like OpenAI, they save all that file. Like, it's not going to garbage. Like they physically save all that file. So all the stuff saved. Same with Alexa. Same with Alexa. Same with Siri. They save all this stuff. Okay, so turn the microphone on. You talk to it. It saved the audio file, right? Now what do you do? So now what you're gonna do is this audio file need to go somewhere, right? So audio file typically it's in a WAV format, right? The WAV format is pretty much no different than MP3. That's the format. That's a standard go-to format for voice. Okay, so you take the WAV file and then you go all the way to here. So let me show you what this thing is. It's some sort of a speech recognition function. It can be an API. It can be a Python function. That doesn't matter. That can be changed downstream in your app, right? So for the time being, I'm just going to use Google API, perfectly fine. And then what that's going to do is it's going to take this audio file and transcribe into text. So the input of that call, of that function call, is a WAV file, and then the response that I'm getting back, it's a bunch of paragraphs. So it's a big string. Okay, so number 3, number 4, 4 comes back to here, and where's here? Here is a voice processor. Okay, so now what do you do? So now you transcribe it, come back, you have this transcribed text, so that takes you number 5, and then from here, you have your text. So from here, you're back to the original framework of a chatbot when people type things down, right? So now at that moment, that audio file becomes a text string, and then everything is kosher, right? You go back to your original strategy, which is you take that text into the API call. In this case, I'm going to use Claude, and then you send that to here. I believe that's Claude in the end, right? Where's Claude? I thought it'd be Claude in the end, but that's okay. So somewhere here, you send that API to Claude, and then it gets you the response back. Now, what I have here, it's a little bit different story. What I have here is assuming that you are loading the LLM locally. So remember 2 lectures ago, what did we say when we want to load the model locally? You need to load the model and you need to load the tokenizer, right? So that's what's happening here. So it's taking the text, tokenize it, because you can't send the text, you can't send a sentence into a model, right? You can only send a number into the model. So tokenizer converts the text into numbers, and then you send the numbers into the model. So that's what's happening from 6 to 7. Number 8 generates a response, and that's how you run the inference locally in step 9. And then you get the token back, and now you got decoded, right? Because token is still a vector, it's still a bunch of numbers, and humans can't read numbers, right? So you have to take the numbers, convert it back into texts, into sentences. So that's what's happening from 12 to 13. And then in the end, it converts the response to speech. And then here, you have to take the text and convert it back into an audio file. And then once you're in audio file, you have to play it back. Does that make sense? So that's the logic here. And then goes all the way back to user. So when it hits the user, it's audio. So this is kind of like a long explanation of what happening behind the scene when you talk to a chatbot and a chatbot talk back to you, right? So all that's happening behind the scene. Now, a couple of issues where this could go wrong. Let me zoom out a little bit. So one problem that is screaming at you from this, it's too complicated. That's like one of the big problems. And you're right to say that it is too complicated. And there are ways to make this easier. Can anyone guess what's the most easiest way to make this easy? Take a wild guess. Like think about how many numbers of API calls I have to make. Like how can we make that easier? Like what's one way to make that easier? No, because Claude is still a language model.
What is the question?
So the question is, the problem with this diagram is too complicated. And the question is, how to make this easier?
So there are a lot of API.
Exactly, there are too many API calls. So how to reduce number of API calls? MCP. It doesn't really reduce API call.
Just streamline.
Yeah, you streamline API call, but it doesn't reduce API call. So think about this way, right? So you talk to it. So start with audio. Audio, say, become a WAV file. You take WAV file, convert to text. And then text you have to send to a large language model. And then large language model generate your response back. And then you send that response, convert into audio, and then you play it. Right? So why can't I just record a WAV file and then give to the model, and the model can just consume that? Wouldn't that just be easier? Right? So the problem there is instead of WAV file to text and text to LLM, you should just be going from WAV file to LLM directly. So a new LLM need to be trained to directly consume the WAV file. That's how you make this pipeline easier. So instead of 2 API calls in and 2 API calls out, you just 1 API call in and 1 API call out. And anyone know the company that does that the best? There's a startup that does that. Yes. Yes. Thank you. If you can get a job here, you're done. Like you can probably retire in a few years. Like this is like everyone wants to use their model right now because they have I don't know how many GPU they it takes to train that model, but it's insanely accurate for some reason. And they don't publish how they train the model, which is crazy. We all look into this. I think they probably need a lot of GPU power. At least that's how I would do it. Like if someone say, here's $1 million, train this model, I would say, okay, $900,000 you probably spend on GPU. That's my guess. But for some reason, they're able to do that, and they're able to do that insanely accurate and insanely fast. So that's going to be something that you guys can think about. Basically, what they're doing is they can reduce this diagram into just 2 API calls, and that's it. And I think right now they can probably do it in 1 API call. Yeah. Any questions so far? It's a wave in, wave out. So sound in, sound out. There's no transcription happening in the middle. Any questions? Okay. Okay. So obviously, assuming that you're not working there right now, assuming that doesn't exist, right? This is still the foundation framework that people do. Now also think about it. If you want to do this, where's the data come from? Like the data still come from this diagram, right? How else are you gonna get the data, right? The data still come from this diagram because you can't just record something from a human and another human respond back and record that. That doesn't work that way, right? You have to somehow send it through LLM to see what a token, like how a token works. So I think there's something there that might be a blocker. I don't know. I don't know how they did it. If someone magically figure out a way that, like let's say you can record your Teams meeting or Zoom call meeting of some sort, and then you chunk the audio file in a way that can make it into like some sort of question answer pair. And then I guess in some way you can probably engineer the data in a way that you can probably pull that off. But that's a big if. I imagine there's a lot of noise going to that data, but whatever. Point being, how you start thinking about this process is still this kind of diagram, step by step, go from audio, record it, transcribe it, send to LM, get a response back, and then convert it back into audio. So once I explain all that, I can probably show you guys the code. Let's start with something simple. Let's just start with the echo bar. And then so that you guys can get an understanding of the capabilities. The echo bar is actually very simple. Transcribe the audio, that's one function. Text to speech, that's a second function. And then process the audio. That's the third function, and that's it. There's no large language model, not yet. That's why it's called echo bar. So let me see if it renders. And let me show you guys what that looks like. Hello, how are you? Hello, how are you? I don't know if you guys can hear that. Hello, how are you? I hear from here, right? Okay. Can you now play on here? I don't know. That's weird. I thought you were able to play on there. Let me see. Okay, but it's fine. As long as you guys can hear, that's fine. Let me play again. Hello, how are you? Okay. Okay, let me go back to the code. And then this app is just the audio in, audio in, go through the transcription process and playback. That's it, right? So to take it from here to the next level, you need to hit some sort of large language model so that the response is like somewhat more intelligent, right? So I'm gonna skip this part just because it's too slow, but I'm gonna leave the code here. What I'm gonna do is I'm gonna jump here to use Anthropic directly, just because it's like much faster. So what I'm gonna do is install this, get my API key, and then I'm gonna run this chunk of code, and then so that you guys can get a sense of what's going on. Hello, can you tell me a joke? And then this is the response coming back, and then
Hi there. Sure. Here's one for you. Why don't scientists trust atoms? Because they make up everything.
can you guys hear?
Hope that got at least
bit,
a
right?
little
Okay.
chuckle out of you.
Okay, now that I explained to you the diagram and I show you guys the interface, what's wrong with this? There's a big problem here. Exactly, it's not continuous. Now the question is, how do you make it continuous?
String.
String is part of it. That's not all of it. There's a trick here to make it continuous. So think about what are the steps. I press this button, I wait for it, I talk to it, and I press stop recording, and I press that button again, process audio or whatever, and then it play it back, and then it display the response in front of me. So how to reduce that? How to make that process easier?
Every time it's not on, we click on process video, it's not going to function ahead.
That's kind of like a hack. It's not a there's a more fundamental solution to this problem. But what you said is kind of like a hack. And you keep always on. How?
Just rather than having that button, you just click it once and then you just have a conversation. But you have to take a pause.
Yes, you're going in the right direction. Okay, so microphone is always on. That's what you said. That is step number one, absolutely. How do you know to stop? Let me take a step back. How do you know to record it?
So when you hear a sound coming in and you start recording, and then once it takes a pause,
yes,
you generate a response at that time.
Yes.
And then you play that response at that time, and then goes back to pause.
Exactly. So exactly what he said. So how to reduce all that crap in the middle, right? I have to click that, I have to click that, how do you reduce all that crap in the middle? You leave the microphone on the entire time, right? Then how does that work? Well, there's a function in the middle to detect if there's sound or not. If there's sound, turn the recording on. And that has to be on the entire time, right? So here's the problem. We can include a push to talk. Push to talk is one, and then what you push to talk is, but then you have to push that you have to do something there. So that's one way, but we're trying to not do anything at all. So what you said is also true. It's going to record everything. Yes and no. It depends on if the company saved that temp file or not. So I'm talking about this thing here. So what you said is an interesting point, and I'm glad you brought that up because I was gonna talk about that anyway. So let's say do what you said. Microphone's always on, and then if there's no voice, fine, right? But if there's any sound, you turn the recording on. But you turn the recording on means you save some audio file, right? And then you have to do something with the audio file, right? And then the problem now becomes, are you going to save this or not? if you like, if I use this audio file, hit the large language model, come back, and I delete this, that would be fine, right? But what if I save it somewhere else and I reuse your data? Then that becomes a problem. So yes.
So in that case, what if we give a fixed length of a sentence that we are called to record? Like suppose
Length of a
just saying
sentence. Okay.
it should not get directly start for the recording. Rather, hi, how are you? The more we are switching up the length.
Oh, like a trigger word.
Yeah.
Okay, yeah, that's what Siri is doing, right? Siri, Google Home, Alexa, they're all doing that, the trigger word. Yes, exactly what you said. Trigger word behaves the same way as what he said. So you leave the microphone on, and then there's some sort of function to turn on the recording, either sound detector or trigger word or whatever magic thing that you want to do, but something has to turn something on, right? Otherwise, how do you know to start recording? So yes, that's another way to do it. Once you decided there's a sound, you turn on the recording start recording the sound that goes into that microphone, and then you have to save somewhere. Whether you delete it later, that's a separate conversation. But at the moment that you want to use for the chatbot to respond to you, obviously it has to be saved somewhere, right? So that's the trick there. So a lot of companies, not companies, a lot of the social media saying, well, you're listening to our conversation, blah 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 blah. How you navigate that debate? Is it truly violating people's right or not? It's the secret is here. Is what you do after you finish this step. If you take this, hit the language model, and then you delete this, I'll probably say that's more towards fair play. But if you save this, hit the language model, and you save this in like another database, and then someone else take that data and retrain their model, okay, that becomes a problem. Then what are you gonna do? Like then you better have a real good reason of why you want to do this. Because if you don't, and if people find out the traces that you did this, then you're gonna be going to lawsuit. Make sense? Okay, so that's a long answer of what's happening here, right? So now let's take a look at the next version of this, and then hopefully after that we're done. Okay, so this is the next version. The system diagram is pretty much similar. What I'm going to do is I think that's fine, but I think I might have to turn the other session off. So I'm going to close this. And then I think I might have to install a couple of things. So bear with me. Okay, so while it's downloading, I'm going to explain a little bit. The voice processing part, I'm using Grok. So that's the API there. Grok has other model, but in this code here, I'm just using the Whisper. So Whisper is the open source model, come from OpenAI. I'm using Grok because I'm using Grok's inference power. So that's the difference here. If you use Hugging Face, it's for some reason it's just slow. So that's why I'm using Grok. Okay. There are two versions. There's voice in and there's voice in, voice out. This one I'm going to leave to you guys to play around. I'm going to demo this one just so you kind of have like a end-to-end version. And even this one, it's like 99% finished. There's like that 1% in the end that I actually personally don't know how to solve. So if you guys figure out how to solve it, then great. And please let me know so I can update my code as well. So I'm going to download that. This package means Google text to speech. So in case you're curious what the package is. Okay, so now I'm gonna run the restart. Okay, so now this should be able to run. I'm gonna let it run and then I'm gonna demo it. And then hopefully you guys immediately see what the problem is. But it's like kind of like a 99% there. There's like that 1% a little bit in the end. that somehow doesn't work with either it doesn't work with Gradio or it works with Gradio and somehow I just didn't know how to solve it. But that's a plan. So let me, oh, come on. That's my fault. I forgot to run that. Yeah. What's that? Yeah. Oh, okay. So let's see. Hi, how are you?
I'm functioning well and ready to help you. How can I assist you today?
I have a math problem. I don't know what is 1 + 1. I think it's 2, but some people say it's 0. Can you explain that to me?
I can definitively tell you that 1 + 1 = 2. 1 + 1
Let's
equals
take it.
2. This is one of the most basic and fundamental mathematical facts. Glad I could confirm that for you.
Okay, let me pause it. So like notice I didn't touch anything, right? I didn't press a button, I didn't touch anything. So can anyone know what the problem is? There's one small problem about this design that's still like just a little bit flawed, just imperfection. Can anyone see what the problem is? What's that?
Is it gonna record your response?
Correct. Yes, that's one problem, but there's another problem. It is recording.
I think
right?
I understand
Whenever I
what
keep
you're
talking,
pointing
it
out.
just keep recording.
After you just said, yeah, a very short,
Let me solve this.
when you just said,
I'll just turn
and
it off. So what you say is true. It keeps recording. But there's another problem. Can someone? Maybe I'll put it here.
I think it's font strength.
Can you see this? Oh, you can't see. Never mind. I already turned it off. Sorry. What did you say?
Response time?
Response time. It's going through a API call. So the API call it's external. So there's not so much I can do there unless you pay for like a more expensive API call. There's another problem. Can anyone spot the problem? Okay, I'll show you guys again. Hi, can you tell me a joke?
here's a classic one. Why don't scientists
Hi,
trust
can you
atoms?
stop?
Because they make up everything. Open mouth smile. Stopped. Let me know if you need anything else.
Was it still playing when you were talking?
Yes, it keep playing when I'm talking. So what's wrong there? That's what you observed, but why it's doing that?
Is maybe, I mean, it could be audio delay or some sort of thing like that, but I mean,
Audio
it
delay.
eventually stops, right? Or was it still playing? Because I couldn't hear as much. Did it eventually stop?
Yes, eventually, obviously, this is finished playing,
So-
right?
Yeah, once it's
But
finished
why
playing-
is it that when I stop it, when I say, hey, stop right now, it kept playing?
Yeah, because you have to have the condition where the user has to not speak, or there should be a pause.
Some sort of.
I think it is completing the answer and then taking a response.
You are almost there. What do you say?
I think probably needs a trigger to stop everything.
Yeah, so put your answer together, then that's the correct answer. So what's happening is we have to go back to how this is designed in the beginning. So how this is designed in the beginning is the mic is on. Right? The mic is on the entire time that the app is on, right? Okay, so mic is on, and then if there's no sound, fine. If there's a sound, turn on recording, right? And then once you turn on recording, if I stop talking, if there's no sound anymore, it stops the recording. And then save the recording, make your API call, get a response back, and then play it. Now, the function in the code that is designing, that is controlling this play audio process has an independent design from whether the mic is on or not in the beginning. So if user keep talking to it before this finish playing, this does not know that. So that's the key here. And you don't know that's a problem until your end user use your app and be like, oh, I try to talk to it, but it keeps talking me back and I can't stop it. Does that make sense? So it hurts user experience, and it is a design problem. Make sense? And I'm just gonna be honest, I actually don't know how to solve it. So if you guys can solve this, please let me know how you solve it. So the code is here. So the code is here. And I can tell you the location. The location of the play audio is as a transcription, text to speech. Where's the audio path? So this is the audio path is here. And then this function is text to speech. So this is kind of like there's nothing here that says anything about where the mic is on or not. Right? The piece of code here is independent from the beginning when the mic is turned on or not, or the recorder is turned on or not. Make sense? So if anyone here can magically figure out how to solve this problem, then please let me know. And the recording button is somewhere up here. Transcribe audio, whisper. There's a recording button. Somehow I can't find it. It's this stuff here. It's this stuff here. There's a state that controls whether sound is and then whether you want to record it. And this is actually far apart from somewhere down there. And there's no connection of these two pieces of code. They're separate. So that's a design problem. That's a design issue of my choice, the engineer's choice, when the engineers designed this app in the beginning. Like somehow the engineer didn't think of that these two things need to be connected. Make sense? So that's the problem. So the question for you guys is how you solve it. Yes.
Actually, I have a question. Let's say we are recording something.
Yeah.
And in the middle of our sentence, we take a break, like while talking.
Yeah.
So will that take our, will it count a break or?
That's a good question. There is a function that detects stop. So there's a detect start and detect stop. The detect stop, once it detects stop, then that's it. Then that's the extent of the recording. Even though the human might be just taking a breath and then they might want to continue to talk afterwards. But that's very difficult to solve. Almost there's no answer to that question because everyone take breath differently. Like I take a 2-second breath, you take a 1.7 seconds breath. No one knows what that means. No one knows how to control that. So yes, that is a problem, but there's no universal solution right now. Any other question? Okay, great. So that's it for today. The code is here. The code is online. If you're interested, play around with it. And if you figure out a solution, let me know. Great. I'll see you guys next week.